All right, so welcome to my class. Let me share my screen first. All right, so can everybody see the slides? Can you see my screen? If you can see my screen, then say yes in the chat. If you can see my screen. If you cannot see my screen, then say no, of course. All right, so yes, very good. You can all see my screen. Then I will start this class. So this is the third lesson of our first unit, our introduction and our basic operations. We have learned order of operations. We have learned evaluation and substitution, which we did last lesson. So for today, we're going to go over some missed homework questions from the homework that I assigned you last week. And I'm going to go over those because these are the questions that most people, a lot of people missed. So I'm going to go over that a little bit. And then we're going to do a review of evaluation and substitution and that kind of stuff. And then we're going to move on to new material, which is combining like terms. And I'm going to go over the distributive property with variables. All right. And then lastly, we're going to do some practice problems. So are there any questions about the schedule? If there are no questions about the schedule, then I will begin. Okay, so let me start reviewing with this homework question that this is mostly, we had a lot of people miss this problem, but mostly there were small mistakes, so make sure you check your homework questions again, your answers, and make sure you're plugging in the right thing. All right, so can everybody just take the time to put your answer with the homework in the chat, and then I'll go over how to solve this problem. And remember, make sure you have a corrections page if you do miss any problems. Okay. And I had some people turn in correction pages, which is really good. All right, so we have negative 38 over 4, okay? Negative 9 1/2 and negative 9.5, negative 9 1/2. All right, these are all correct answers. Very good. So a lot of people, what some people missed was this. Okay, so let me show you. So what some people did was they plugged in the 1/3 instead of the negative 1/3. So make sure you pay attention to this negative sign here. Okay, so it's pretty easy from now on. So usually, well, the first problem of the homework is going to be pretty easy. Okay, so basically you just plug it in. Okay, over 4, there we go. And then make sure you do this first order of operations. 12, first, let's do 12 times 1/3, which is basically 12 over 3, which is 4. Then add the negative signs. Maybe easier for some people to think about it that way. So negative 4 minus 34 is going to be negative 38 over 4. And I had some people just turn it in as negative 38 over 4, but that is not fully correct. I may give you some partial credit, but this is not simplified. And when you get to middle school or high school, they're going to count you off if you don't simplify it. So make sure you can simplify, make sure you simplify. So negative 19 over 2, that should be the correct answer. Or you could have said negative 9.5 or negative 9 1/2. But the thing is, with negative 9 1/2, make sure, since when you get into higher level mathematics, they want you to put it in proper fraction. All right, so make sure that usually your answers are either decimals or simplified in proper fractions. All right, make sure you do that. All right, so no questions about this homework question, right? No problems with this? Yeah, okay. Okay, so no questions, then I'll move on. So our second homework problem that we're going to look about here. So evaluate v plus 1 over w squared if v equals 8 and w equals 2 3/5. Again, usually the problem with this is that you don't check your answers and you do some small mistake, stupid mistake, careless mistake. Make sure you don't do that, okay? And again, some people did not simplify, so make sure you simplify. All right, so I'd like everybody to take the time to just put your answers in the chat, and then we'll go through this. All right, so most of you guys got 25, which is correct. Okay, very good. And we have one more and also 25. All right, that is the correct answer. Very good. So let's look at this. So v plus 1, basically 8 plus 1. So first step, just plug everything in, right? Plug everything in. W 3/5 squared. Okay, there we go. At the top, it's going to be 9. And then the exponent. Basically, when you square a fraction, all right, so just a note here. Just a quick note. When you square a fraction, okay, this basically equals a squared over b squared. So if you're squaring 3/5, then it's going to be 3 squared over 5 squared. Okay, so, and also, I know a lot of you have learned this in 5th grade or 6th grade. When you have this big number 9 divided by another fraction, what happens when you divide by a fraction? You basically multiply by its reciprocal, okay? So make sure multiply by reciprocal. Okay, so when you multiply by reciprocal, basically what you're doing is 9 times flip the fraction, 5 squared over 9. And you see here that since we're multiplying and dividing by 9, these two 9s cancel out, so you get 5 squared, which is 25. Now, some people just left it as 9 over 25, and that is incorrect. Remember to simplify. All right, simplify. That is big idea here. Make sure you simplify your answers, okay? So make sure you do that. So are there any questions on how I solved this homework problem? There are no questions. Yeah, you forgot to that you could simplify. So make sure that next time you do simplify, and or I'll count you off. So make sure you take your answers very well. All right, so this one, also a lot of people missed the correct answer, because I'm not going to tell you the correct answer yet, because a lot of people missed this. So how about you guys take the time to put in your answers in the chat, and then I'll tell you the correct answer. So let's see, we have C, very good. Okay, are there any more answers? We have C, very nice. All right, so in the homework, some people put A because they subbed in the incorrect number. Again, they forgot this negative sign. So if you sub in 1 instead of -1 for A, then A is actually true, because 1 squared plus 2 is equal to 3, right? So then A would be correct, right? But we have -1, so make sure you do this properly, okay? Make sure you check. So obviously A going to be -1 squared minus 2 is equal to 3. It's not equal. Okay, and then we have -1 over 5 plus 5 is equal to -8. Obviously, that's also not equal. Okay, and then we have C, which is the actual correct answer. Okay, and we have -1 minus 1 times -2 plus 1 is equal to 2. And that is equal to 2. Basically, it's -2 times -1. And when you multiply two negative numbers, get positive, it's just 2. But before, if you get this correct answer, don't just go to the step and move on. Make sure you actually do the last one, because sometimes you may make a mistake, and if the last one is the actual correct one and you have two correct answers, then you probably did something wrong. Okay, but you can see obviously that this last answer is not correct, and C indeed is the correct answer. And I also had some people actually show their work for all of them, but they never chose any answer. Okay, so make sure in these multiple choice problems, not only do you need to show your work, you also need to actually choose a problem where you didn't answer the question, right? So make sure you do that. Okay, and then let's review some substitution. A few review slides, and then we're going to move on to new material. All right. So let's review substitution. So the definition of substitution in mathematics is plugging in a number value for the variable in an algebraic statement. Okay. Or actually, this is incorrect. An equal value is correct. But we usually do the number value, but the actual definition here is incorrect, so sorry about that. What I mean by an equal value is, let's say you have ax plus by is equal to c. But we also know that x is equal to y minus 3. And since these two are equal, then you can plug in y minus 3 for x, right? So that is basically substitution. So it doesn't always have to be a number value. But again, if you do know that what variable is, like we know that what x is equal to 3, then we can plug 3 in instead. But usually when we're dealing with Algebra 1, we're in the early stages of Algebra 1, we're mostly going to be subbing in number values, okay? So some examples. I just showed you example. You can do another one. So basically this is 5a plus 1 if a is equal to 3. So basically what you do is plug a in, and this is pretty self-explanatory. You get 16. All right. So those are basically substitution. Pretty easy, right? And then let's review some examples, all right? So evaluate 5s plus 7 if s is equal to -2. All right, so I'd like everybody to do this in the chat right now. Put your answers in the chat. I know that we've done this before. I just want to review a little bit. Okay. So we have a couple answers, -3, yeah. Pretty self-explanatory, right? -3. So most of you got -3, and that is correct. So what is our first step? First step, plug in -2. 5 times -2 plus 7. Why can we plug in -2? In our last slide, I told you that since s is equal to -2, they can be used interchangeably. So because 5 and 7 are both numerical values, then we want another numerical value so we can actually evaluate. this statement, right? So from this, we can get -3. Okay, -10 plus 7. All right, so let's review our example 2. So determine the validity of the statement 2x to the 5th times x minus 2 squared times x plus 8 is equal to 0 if x is equal to 0. Basically, you're saying that if x is equal to 0, is the statement true or not? So I'd like you to put true or false in the chat. Okay. You have one answer, and it is true.
Can I see the question again?
Okay, yeah, you can see the question. I'll put it up for a couple moments, and then, yeah, put your answer in the chat box. All right. Let's see. True. Most of you had true. And Isabella, you said that I gave you a 0 for you. Actually, let me check right now. Hold on a second. I don't remember giving too many zeros, so it may be a mistake. Are you sure you turned it in? Isabella, your homework. I did give a couple of zeros, but those were for people who did not turn it in by the due date. Oh, you forgot to click submit. So that's the problem. So let me check if you submitted it. I should be able to see. Actually, let me save this for after class. But if you have not submitted it, just click the submit button right now so I can grade it later, all right? And if anybody has that same issue where you forgot to click submit, it's okay. I can accept like a couple days late, all right? If your homework is just a couple days late, I understand, and I will give you a full grade for that. Okay, so determine the validity of the statement. Well, we don't even need to solve the rest of this, right? Just plug in 2 times 0 to the 5th and times x minus 2 squared times x plus 8. Well, 0 to the 5th, all right, we talked about this last class, that everything multiplied by 0 is going to be 0, right? So if we just have a 0 here and everything is multiplied by it, then everything is going to be equal to 0, right? So this is true. Okay, and when you see problems like this, make sure you look through the problem first, because you might not see like obvious solutions, very efficient solutions, and you actually go through the whole thing and solve everything, but it's not going to be very efficient. All right, so let me go on to the next subject for today, which is combining like terms. All right, so what are like terms? Like terms, the definition of like terms are mathematical terms that share the exact same variable and the same exponent, all right? So can anybody give me some examples of like terms, all right? They share the exact same variable and the exact same exponent, all right? So
2y plus 3y.
very good. So in our like terms here, we have 2y plus 3y, and everybody else, please show me some examples of like terms in the chat. All right, so so far we have 2y plus 3y. Very good, whoever that said that. Okay, we had 2x plus 2x. Very nice. we have, what do we have? Yes, Aaron, that is actually true. 1, 2, 3, that big number, can't actually say it. But as long as they share the same variable, all right, they're going to be like terms, all right? And we have 2x plus 2x, 2x plus 2x. All right, what else do we have? We have a lot of examples. We have 5x squared plus 2x squared, yes. And we have a lot of examples, all right? 5x squared plus 2x squared. All right. Very good job on all of these like terms. But let me give you a question. Are these terms, hold on. Are these terms like terms? 3x squared plus 2x plus x cubed. Are these terms like terms? I mean, they share the same variable, right? So can you combine them? Are they like terms? No. All right, we have no, and then we also have yes. Okay, so we're 50-50 right now. Are there any other opinions? Are these three terms like terms? All right, are these three terms like terms? So say yes or no in the chat if you think yes if these are like terms, or no if they aren't like terms. So we have yes, no, yes, yes, no, yes, yes, no, yes, a lot of yeses, and then no, they are not like terms. Okay. And Eric also says no. Aaron says yes. Okay. We have a lot of opinions. Very good. So the thing is that they're actually not like terms. You can't actually combine these. Why? Because a lot of you guys overlooked the second condition here. They need to have the same exponent, all right? They need to have the same exponent, and we have x squared, x or x to the first power, and x cubed here, and they are not the same exponent. All right, they're not the same exponent. Okay, so the answer is no. Okay, the answer is no. These terms are not like terms because they don't share the same exponent. All right, so make sure you this like a subtle point here. You make sure that when you're looking at these terms, make sure that they have this exact same exponent, or you cannot combine them. Obviously, when you're looking at something like 2x plus 2y, obviously that's not like terms. These are not like terms. But then when you look at 3x squared plus 2x, they're very similar, right? They do share the exact same variable, which is x. So make sure you pay attention to that and avoid making mistakes. And people are spamming in the chat, so yeah, I know. Okay. All right. So now let's look at a bit of distributive property. Okay, so everybody who has learned about distributive property before? Have you all learned about just associative property? What's the other one? Distributive property. Well, I know there's
Commutative.
three properties. Oh yeah, commutative. And I have no idea what the other two do, but they're just common sense and math. I'm pretty sure the other one was like A times B times C is equal to A times C times B. Is that associative or commutative? No idea.
Commutative is like rearranging the numbers, and then associative is like moving the parentheses.
I see. So
different ways of arranging.
yeah, okay. So very good explanation. So basically, this is associative, right? A plus B plus C. All right, I have a feeling I learned this before, but I forgot. But basically, this is like kind of already common sense when you learned this kind of algebra. One, you guys all already know this, right? And commutative is A plus B plus C is equal to C plus A plus B. You can just rearrange them, right? But the big idea here that not all people know when they're learning Algebra 1 is this distributive property, and that's why we need to learn it, all right? So we have A, B, and C, three variables. They can be anything. B can actually be a variable. A can be a constant. C can be a constant. Doesn't matter, all right? So when you have A multiplied by B plus C, or we say A times the quantity of B plus C, we get A times B plus A times C. So this is why it's called distributive property. So when we have this, we distribute the A to both terms, right? So we get AB plus AC. So make sure you distribute like A to both terms, not just one term. And that's a common mistake when you're learning this. Okay. And also, so let me give an example first. So let's say we have 3 times x plus 5, all right? So we distribute the 3 times x, and 3 times 5. So the answer is not equal to 3x plus 5. You only distribute the 3 to the x. What you need to do is you need to distribute it to both terms, okay? So you get 3 times x plus 3 times 5, then you get 3x plus 15, right? So here's a subtle point that a lot of people don't know about when they're learning Algebra 1. Mostly the application of the distributive property in Algebra 1 is mostly going to be like multiplication, right? But it can also work for also works for division, right? No, also applies. Okay, that's bad. Okay, it applies for division. All right, it also applies for division. So when you have B plus C over A, if this is kind of hard to think about, we can say when you have B plus C over A, it's basically multiplying B plus C by 1 over A, all right? When you think about it that way, then you know that this also applies for division. We get B over A plus C over A, all right? It also works for addition. I mean, division. All right. So any questions about this distributive property? Pretty self-explanatory, right? How to distribute division? How to distribute? Okay. Do you want me to explain this again? So basically, right here we're multiplying A by B plus C, right? But this time we're dividing B plus C by A. All right, we're dividing, but it basically is the same, right? So when you're dividing, also you need to distribute, right? Also distribute to both terms, but this time it's not AB or AC, it's B over A plus C over A, okay? So, but don't worry too much about this. I'm not gonna get into much of this fractions too much in this early stage of learning. And I'll also, since we're not directly learning about like fractions with variables, combining fractions, that kind of stuff, or factoring or anything like that in this early stage, I'm not going to go too far in it. And when you actually get to that unit, then I'll explain it more deeply. So don't worry about it yet. Okay. Okay, you get it now? Very good. So let's go over our first example. All right, our first example. So let's do this example. I'll give you a few moments to try and do this. Actually, yeah. So make sure you pay close attention on how to do this. Right. So I'll give you a few moments to try this example. And then after we go over some examples, then I'll do some practice problems with you. And of course, usually these examples are going to be directly based on the definitions that I gave. They're going to be relatively easy and compared to the practice problems. So I want you to think by yourself when you're doing these practice problems. And in these examples, I'll walk you through it. But these practice problems, make sure they're going to be a bit harder. So make sure you check your answers and whatnot. And of course, mathematics is not just about like memorizing all of these definitions, knowing how to just memorizing them, doing them. You also have to know how to apply them to more challenging problems, because usually in algebra 2, calculus, pre-cal, you're not going to be solving one equation. You're going to work with a lot of applied problems. So make sure you know how to, solve equations, combine like terms. They're all steps towards that final answer. And while I'm rambling on, you can just post your answers in the chat box. Okay, we have 14d to the 5th minus 18d to the 6th. And then we also have negative 14d to the 5th minus 18d to the 6th. And okay, so Kaylee asks, how do you write an exponent using the keyboard? All right, just as how Genevieve and Ethan wrote it. All right, use this, what is it? I don't even know what that thing is called, but I think it's shift and then 6. Yeah, that thing, that arrow pointing thing, pointing to the top, that thing. Basically, if you type that thing, it's basically saying exponent. But yeah, that thing. Yep, a lot of those things. Shift plus 6. I don't even know what it's called. It's called a caret. Oh, okay. Why is it called a carrot? Why not called a potato? All right. Can you show associative property again? Associative. It's basically hold on. Let me go back to the slide. Associative. Basically, associative. Let me just make a little note here. For those who do not know associative, it's basically when you have like multiplication or division, okay, like A plus B plus C, you rearrange these parentheses, right? Because 3 plus 4 plus 5 doesn't matter which one you do first, right? So this is going to be you can also rearrange it like A plus B parentheses plus C, or you can say A plus parentheses A B plus C, right? Basically associative, like the parentheses, rearranging parentheses. But it's pretty easy, pretty self-explanatory, so don't worry too much about it. All right, so all right, very good. You oh, it's called a caret. A carrot, not a carrot. Okay. All right, so we still have some confusion over the difference of associative. So I talked about associative now, so I'm gonna go back and talk a little bit about commutative now. So commutative. Wait, is that how you spell it? Right. Commutative. Commutative. How are you supposed to pronounce this? Okay, commutative. All right. Basically, commutative property is going to be basically, instead of rearranging the parentheses, now we're going to rearrange the actual, like, the numbers. So if A plus B plus C, we can arrange that as B plus C plus A, right? Like 3 plus 4 plus 5 is equal to 4 plus 5 plus 3, right? Really easy stuff. Again, distributed properly is really the one that you want to worry about, but commutative and associative, they're pretty easy. Is there any more? Oh, communism. Yes, commutative. Commutative does sound like communism. You know, everybody has a communism heart in them. All right, everybody does. You know, communism is cool, but I agree that it's not good for a government. Yeah. Okay, so not good at politics either, so let's not talk about communism right now. All right. What is good for a government? Not much these days. All right, so let's look at your answers. Negative 15d to the fifth. What you need to do is you need to just use different colors to highlight these like terms. So you have d to the fifth right here, and make sure you don't combine d to the sixth and d to the fifth because they don't have the exact same exponents. So you can't do that. So let's take another color and let's do to the sixth, right? Basically, just combine these terms and combine them. Okay, so negative 15d to the fifth plus d to the fifth, that's going to be negative 14d to the fifth, negative d to the sixth minus 17d to the sixth, going to mean minus 18d to the sixth. All right. So it's pretty self-explanatory, right? Pretty easy. No questions, right? So now it's multiply 5 times the quantity of x plus 6. Now, this is pretty easy example, so I'm just not going to have you guys solve it right now. I'll just walk you through it. Again, distributive property. Make sure you distribute it to both terms, right? So 5x plus 6. Is that the correct answer? This is a mistake that a lot of people make, all right? So make sure you distribute it to both terms. If you don't, then you get something like 5x plus 6. The correct answer would be 5x plus 30, all right? So make sure you not just distribute it to the variable, you also have to distribute it to the constant in this parentheses, okay? So don't neglect that 6. All right, yes, 5x plus 30, very good. I like the fact that nobody made that stupid mistake. And pay attention so that you don't make that stupid mistake in your homework either. Okay. Oh. All right, practice problems. Number 1, simplify. I'm not even going to read that, but for the commitment to this class, I will. 3g squared times h minus 4gh cubed plus 22 minus 2g squared h minus 30 minus g squared h plus 4gh cubed plus 4k. All right, I'll give you a couple moments to do this problem. And if you do have any color pencils, you can just highlight these like terms. It is pretty helpful when you're just beginning to learn about combining like terms. But of course, this is pretty long problem, so I will give you a sufficient amount of time to do this. But a thing to note when you're doing these kind of problems is that a lot of people who create these problems just make a lot of these terms cancel out. So make sure you like, let me give you a hint. For example, 3g squared times h minus 2g squared times h minus g squared times h. It all cancels out, right? So a lot of these terms cancel out, which isn't really it isn't really a big deal anymore, right? It just cancels out till it's just a very small mathematical statement. So make sure you check your answers, especially with combining like terms. It's very easy to make mistakes. So make sure you pay attention and do the problem carefully. All right. So I'll give you a few moments to complete this problem. All right. So I'll leave this slide up. Then you can put your answers in the chat box. All right, we have 9 answers. Okay, we have 4k minus 8, negative 8 plus 4k, all of this stuff. 4k minus 8. We have a lot of 4k minus. Okay, very good. We have all the correct answers. Right, all of them are correct answers, assuming that they are correct answers, because I actually haven't solved this problem yet. But a lot of you agreed on the same answer, so let's assume that it's correct, hopefully. But let's start again. I give you that little hint. These 3 terms basically cancel out, so you don't need them anymore. What is this? Negative 4gh cubed, positive 4gh cubed, canceled out. What is this? 22 minus 30, easy, negative 8, plus 4k. We're done. It's actually very easy, right? So don't let all of these big mathematical statements seem very daunting, right? They're not that scary, okay? There's a lot of these terms cancel out. And just a little, I'm going to make a note here. Negative 8 plus 4k is correct. Although we have something called the standard form in mathematics or algebra. So standard form. Make sure largest variables. So basically, variables with the largest exponents first, constants. All right. Basically, this is standard form, right? So we actually put our variables first, all right, with the largest exponents in case you have more than one variable. And then the constant is going to be put last. So negative 8 is going to be put last. So it's going to be 4k minus 8 here. So just to practice with standard form, I'm going to give you a little example here. So we have 3x plus 4y squared plus 3y. Actually, no. say 4y plus 5. All right. How are we going to put this into standard form, right? So make sure you get your biggest variables, basically the largest, the x, well, the variable with the largest exponent, right? So which is y squared. So 4y squared, and then you look at 3x plus 4y. Well, there's a coefficient here is going to be larger than 3, so 4y and then 3x plus 5, right? So that's how we put it in standard form. Now, standard form, basically why we have standard form, it looks good. Okay, it looks good. Like that, I can only think of that. That's the only reason, but I'm pretty sure some smart guy made it up a long time ago, so it's probably important somehow, but it looks good. And also make sure that I don't even know why, but it doesn't, even if you got -8 plus 4k, it's the same thing, right? 4k minus 8 is the same exact thing, right? Why? Because, what was that called again? Rearranging the number. Oh, commutative. Yeah, commutative property. That thing. That thing that we learned that I forgot about. Yep, that thing. Yes. Okay. So make sure you put your answers in standard form, variables first, that kind of stuff. All right, so let's look at some practice problems. And our second problem here, right? Multiply -18 times 1/2 x minus 2/3 y minus 1. Okay, let's do this. All right, so let's look at some answers here. We have 4 answers so far. 12y minus 9x plus 18. We have -9x minus 12x plus 1. Okay. So we have some conflicting answers here. All right. Let's look at which one is correct. So remember, distribute it to all terms within the parentheses. So -18 times 1/2. It's going to be -9. So -9x. Since we're multiplying -18 times -2/3, it's going to be positive, right? So make sure you have that positive sign. And 2/3 times 18, that's going to be 12. So 12y. And then lastly, we have -18 times -1, which is plus 18. And put this in standard form.
Shouldn't
12y minus 1.
the plus in the middle be a minus?
The plus in the middle would be a minus.
Yeah.
Which one? This one?
The -9, yeah, that one.
This one? All right, so why is this a positive? Well, basically, what we're doing here is we're going to multiply -18 times negative 2/3 times y. And if you multiply two negative numbers together, basically these negative signs cancel out.
Please.
Yeah, so do you understand now?
Yeah.
All right, very good. And Kaylee, I think you forgot to distribute the negative 18 to the negative 1. All right, so make sure you do it more carefully next time so you don't miss that fact. Okay. And we also got 6xy minus 1. So I don't know how we got that, but okay. Answers all over the place. But this is the correct answer, 12y minus 9x plus 18, right? For those who did get incorrect answers, pay attention to how I did it and make sure you do not make such mistakes in the future. All right, so let's look at this practice problem. Simplify 6 times the quantity of p plus 3q minus the quantity of 7 minus 4q. How are we going to do this? I'll give you a few moments to put your answer in the chat box. And all right. So we have a couple answers here. We have 14q plus 6p minus 7. We have the same answer from Eric. All right. 6p plus, yeah, same answers. And then we also have a 22q plus 6p minus 7. All right, different. We also have 53 plus 14q, also different. 6p plus 16q minus 7. And then 20p minus 7. All right, so, oh, okay. Isabella said 14, not 16. Okay. So we have some conflicting answers here. So let's see which one is correct. Remember that we have distributive property here. 6p plus 18q. All right, that's our first part. Now, the second part is what a lot of people miss. We don't have any number in front of this 7 minus 4q, just a negative sign. So how are we going to do this? Looks a bit weird, right? Well, think of this negative sign as negative 1. All right. Then you can see negative 1 times negative 7, negative 7. And then we have negative 1 times negative 4. So it's going to be positive 4q instead of just negative 4q. So positive 4q combine like terms. All right. You get 22q, okay, plus 6p minus 7. All right. So who got 22q plus 6p minus 7? All right. But Ethan, very good. Congratulations on getting the correct answer. Very nice. All right, so does everybody else understand why you were incorrect? All right. Remember this, you have to distribute this negative 1 to the negative 4, all right? So instead of subtracting negative 4, we're actually going to be adding negative, positive for Q. Okay, so we're running out of time, so I'm just going to walk you through this for the next few problems. All right, so let's make sure we end in time for this one. So this one, 4RS minus 2S minus 3 times the quantity of RS plus 1 minus 2RS. Okay, so immediately we can see that by the order of operations, we need to simplify this distributive property here. Okay, this parentheses, make sure you distribute both of them, okay? And what you get is 4RS minus 2S minus 3RS minus 3 minus 2RS. Okay? So then what we do is we need to combine like terms, okay? Like this itself, and then we have our constant, okay? So these are our different terms here. So let's go back to blue and then, so we're subtracting 3RS and negative 2RS from 4RS. So basically negative RS. And when you're multiplying two of these variables together, usually you would put these two variables at the beginning, okay? And then we have subtract 2S, then minus 3. Okay, so this is our final answer. Right. Philip, you get it now. Okay, very good. And then are there any questions about this answer to this question? If there are no questions about this particular problem, then I'll move on to our next one. Okay, so we have another distributive, well, parentheses here. So make sure you use distributive property, distribute to both terms. Okay, so you distribute and then use just multiply it out, then you get 21x plus 14y plus 12x minus 1. Okay, then see we have some like terms here. Okay, we have the x's, then we have the y, right? And then finally we have our constant. Okay, let's go back to blue. Okay, so then 21 plus 12x, okay, it's going to be 33x, all right, 33x plus our 14y minus 1, right? Any questions on this? If there are no questions on this, all right, then let's end this class now because I already, the time limit is already up. Okay, so I don't want to take too much of your time. And so thank you for listening, everybody.
When will you send out the homework?
All right, I'll send out the recording and the homework possibly tonight or tomorrow morning. All right, and I'll make sure to send out the homework because I have it ready already. All right, bye everybody. Thanks for coming. Okay.
Bye.
Bye. See you next week.
Bye.